Welcome to the deep dive. Today we are getting into a really fundamental piece of professional audio gear, the DBX223XSV crossover. And our mission really is to figure out how this unit, which goes for about $290, how does it deliver the kind of extreme precision you need to stop subs from getting muddy in these huge sound systems?
Well, you can think of it as the traffic cop for your sound.
Okay, I like that analogy.
Yeah, Harman makes it, and its job is just so critical. It takes that one full-range signal, and it just splits it up. Lows go to your subwoofers, mids to your main drivers, highs to the tweeters. Without that precision, it's just chaos.
Frequencies just canceling each other out.
Exactly. You lose all your clarity.
So if you're chasing professional results, it sounds like it starts with the math. What makes the way this unit splits frequencies the industry benchmark?
It really all comes down to the filter.
The 24 dB per octave, that's the key, right?
That is the professional standard. It's chosen because it guarantees perfect phase coherence right where the frequencies cross over.
So the signals blend together seamlessly.
Perfectly. And that is a huge, huge engineering headache solved in multi-way speaker systems.
Which makes me wonder, if that's the gold standard, why would anyone use a simpler, say, 18 dB slope? Is the difference really that audible?
Oh, absolutely. With shallower slopes, you get phase issues, and you hear it. You hear it as a little dip in volume, maybe a weird filtering effect right where the mids meet the highs. The 24 dB standard just minimizes that. Plus, the unit itself is built for it. High quality XLR, balanced inputs and outputs, everything you need to reject noise over long cable runs.
So the filters handle the split, but the real power has to be in correcting for, real-world problems. Bad speaker placement, things like that.
Correct. And you've got instant versatility. There's a mode switch right on the front. You can flip it to stereo two-way for a smaller setup, or go to mono three-way if you need more discrete control, like for stage monitors.
And when it comes to the actual tuning, the controls look incredibly flexible. I'm seeing independent gain controls for level matching, but the thing that really stands out is the phase reverse switch. On every single output. Why is that so vital?
Because it lets an engineer fix time or polarity errors on the fly. Let's say your subs are physically 6 feet in front of your main speakers.
So the sound arrives at different times.
Right, and that can make your low end sound weak or, muddy. Flipping the phase can snap those waveforms right back into alignment, makes everything tight again.
And it looks like it can scale up to massive systems, too, with that by 10 range switch.
Yeah, that just multiplies all the crossover frequencies. So in stereo mode, your range jumps from a sub-friendly 45 to 960 hertz, all the way up to 9.6 kilohertz.
So one box can run a giant concert system or a tiny studio monitor setup.
That's the idea. Total adaptability.
Okay, let's talk about managing the really low stuff. There's a built-in 40 hertz high-pass filter.
A low cut, yep.
But this one uses a 12 dB octave Butterworth filter. Now that's interesting. We know why Lenkwitz-Riley used for the crossover, but why use Butterworth for this cutoff?
That's a great question. It's about intent. Lenkwitz-Riley is optimized for phase alignment where two bands overlap. The Butterworth is designed to be maximally flat in its response right up until the cutoff point.
So it's more like a very clean brick wall.
Exactly. It's there to protect your subs from subsonic information stage rumble, DC offset stuff that just wastes amplifier power without making any audible sound.
And for system design, there's also that LF sum switch.
Yeah, that's a neat feature. It lets you sum the low frequency output to mono.
Which is great if you're running a single center clustered subwoofer stack.
It is. Very common setup for max bass impact, and this just simplifies your wiring completely.
Connecting all these specs to what you get in the real world, the build quality feels solid, but the fidelity metrics are just wild. The dynamic range over 106 dB, and the THT plus noise is less than 0.004%.
I mean, that's incredibly low. And functionally what that means is that the crossover itself is adding zero audible noise, no grunge, to your clean signal. You can push your system really hard and know the signal going to your amps is mathematically pure.
So at the end of the day, the DBX223XSV is just a workhorse. It's this blend of high-end filtering, flexibility, and serious fidelity.
It's a precision tool, pure and simple. It just solves the core problems of multi-way audio, phase incoherence, and signal integrity.
Right, so here's something to leave you with to mull over. We all know that human hearing basically tops out around 20 kilohertz. And most digital audio you listen to, it doesn't even have information above that.
Right.
So why would DBX go to the trouble of building a unit that has a frequency response that goes all the way up to an astronomical 90 kilohertz? Is it just about having maximum analog headroom, or is there something else going on? Could it be critical for preventing distortion deep down in the range we can hear? That's your deep dive homework.
Yeah,